Chapter 2, Lesson 1 of Geometry, looking at conditional statements, and in this video we want to look at the truth value. A conditional can have a truth value of true or false, so you only have two options. The truth value of the conditional can be either true or false, which simply says that the conditional itself can be true if you can show that every time the hypothesis is true, in other words, every time the condition is met, then the conclusion is also true. In other words, when you place a condition on someone, you say, if you do this, or if this happens, or if, whatever it may be, that condition, if it ever gets met, then the conclusion must happen. If it's true, then the conclusion must happen. If it does, then the truth value of that conditional is considered to be true. If, however, you can show that the hypothesis is true, in other words, you can meet the condition, but you can have a different outcome than the conclusion says will happen, then that conditional is said to be false. Now, in order to show that a conditional is false or has a truth value that is false, you have to give a counterexample. We've used those earlier this year. A counterexample where you can show the condition has been met, but you can get a different outcome, or the conclusion can be different than what the conditional states. All right, so quickly putting that in our notes, the truth value, it can be either true or false. If it's true, the hypothesis is true, and the conclusion also is true. If it's false, you still have a true condition, meaning you still meet the condition, but a different outcome happens rather than what the conclusion says should happen or will happen. And again, the only way to provide or to show that the truth value is false is to actually give an example where you show, look, I've met the condition, but I'm getting a different conclusion even though I've met your condition. So for example, for finding a counterexample, if the month is February, then there are only 28 days in the month. So is this a true or a false or a conditional? So in order to prove that this is false, you would have to show a month where there are only 28 days in the month. No, I'm sorry, you'd have to show a month where it's still February, but there are not just 28 days. So can you give an example where it's still the month of February? You can meet the condition that the month has to be February. However, there are not 28 days, or some different amount of days. And actually we can do that if we think about a leap year, because in a leap year in February we meet the condition, but there are 29 days in that month, so I get a different conclusion than what the conditional says I should get. So that's how you prove a conditional false, okay, by giving a counterexample. So another example here, well, almost showed you the answer. If the name of a state contains the word new, then the state borders an ocean. So in order to provide or to show that this is a false conditional, you have to give me an example where the condition is met. So you still have to give me the name of a state where it has new in it. However, you get a different conclusion, meaning that that it's not on the border of an ocean. Can you think of one? Well, that would be New Mexico, because New Mexico meets the condition of having a state with the word new in it. However, I get a different conclusion than what is given. So that is how you prove a conditional false, is by giving a counter example. All right, so I want to talk about Venn diagrams as well, and we can use Venn diagrams to illustrate conditional statements. And here's how it always works. The only diagrams, the Venn diagrams that we're going to use, are two circles, and in the smaller circle you will always place the hypothesis. So the hypothesis will always be in the smaller circle, and then in the larger circle that will be the conclusion, and that will never be different. Okay, the conclusion will always be in the larger circle, the hypothesis will always be the smaller circle. So if we were wanting to draw a Venn diagram to illustrate this, if you live in New England, then you live in the United States. So what would go in the smaller circle? That would be the hypothesis. And in here the hypothesis is you live in New England. So that is your hypothesis. The conclusion is you will live in the United States, or you live in the United States. So this would be conclusion, so that goes in the larger circle. So that's how you draw a Venn diagram. Now you should be able to go backwards with this as well. So if I give you a Venn diagram, you should be able to write a conditional if, and then this will be your hypothesis, then, and then this will be your conclusion in the outer circle. Now let's see if I have one more example. Carrots are vegetables. Now here's an illustration where we don't have an if-then. However, we could write it as an if-then. If the item is a carrot, then the item is a vegetable. So carrot would be the hypothesis, and vegetables will be the conclusion. So our Venn diagram would look something like that. Okay? Now here's one where you would go backwards. You have Olympians and athletes. And again, remember, we want to use words that help us make sense. So the hypothesis is the Olympian. So if the person is an Olympian, then the person is an athlete might be something that you could write. Again, hypothesis being in the smaller circle, the conclusion being in the larger. Here, and again, if whole numbers, then integers. That's kind of the basics of it, but now we need to fill it in with English that helps it make sense. So if the number is a whole number, then the number is an integer. Remember, I'm not using the word it or they. Alright, so that's truth value and Venn diagrams when we're working with conditional statements. We'll have one more video where we take a look at converses, and then that'll wrap up lesson 1.